This week is week 7. In the next 2 modules, we will introduce stack and queue template. This week, we will start with the stack template. So stack and queue template is another 2 data structure we will implement these 2 weeks. In order to either implement stack or queue, we have 2 approaches. We can either use array implementation, similar like our dynamic array template we had that last few weeks. And we will introduce you another way. We will do the linked list implementation. So then we will also compare what's different between array and linked list. So then this week, assignment 7, we will do the stack template. We will implement the stack template, and also you will have the part 2 is the calculate. We will simulate the calculator to using the stack template. After we finish module 7 and 8 on the stack and the queue, we will have our midterm exam. So our midterm exam always happen in week 9. So for the Monday, Wednesday class, we will have the midterm exam on Monday. So usually if I have the hybrid class, the same thing, I will have the midterm exam on Monday in week 9. So that's the first thing. Let's talk about the stack and the queue template. So stack and queue actually, they are one kind of data structure. And also we say they are templates. That means no matter which stack or queue, we should be able to use any data type. So our stack or queue data structure should be able to store the data we want to store. So we will implement the stack or queue class as a template class. So as we say, actually all the data structure we try to store data. For array we implement in the past couple weeks, your array can be accessed through the index. So that's one kind of data structure we have. So now when we talk about the stack and the queue data structure, they have different characteristics how they store the data. So we talk about stack. So stack actually they have the first in, last out nature to store the data. That's me. The first data I store, actually that will be the last one being out from the stack. So just like the array we have in the past couple weeks, the stack can store different data type, but all of them should be the same data type. So the stack, we say the first in, last out. Then we have queue. So the queue is the first in, first out. That means the first object I push to the queue, that will be the first one pop out from the queue. So that's why you can see stack and queue, the order, no matter they do the first in, last out, or first in, first out, the user has no way to control which one will be pop out, because they will always follow this order. The first object in the stack will be the last one pop out from the stack. The first object push into the queue, they will be the first one out of the queue. So that's why you see, since you have no control of the stack or queue to access any object you want, because they always follow the order. So that's why unlike array, they are not meant to allow to access any value. They always need to follow the order. So then you will see, so the queue will only have the oldest one you will be pushed. So you will be pop from the queue. So then you always have the newest one pop from the stack. So for the stack and queue, because they follow that order, so that's why you can always push into the data structure. But which one you can access next, the queue will have the oldest one you can access, because the first in, first out. then your stack will be the newest object you can access. So this week, let's talk about the stack example. So next week, we will do the queue. So just like we say, stack is, you can either say first in, last out, or first in. So, or the last in, first out. So either way, they will have the newest one will be pop out from the stack. So whenever was the last value stored into the stack, that's the one to be retrieved, or if we want to remove. So that's why we have couple operation from the stack. So the first one we call push. When you want to insert an object into the stack, you push in. So then when you want to pop the object out to the stack, you use the pop. Or the other one is, I just want to take a peek. I just want to see which one is the newest object from the stack. So then we will check. Sometimes they either return the copy or return the reference. So that's the peek. The stack implementation also have the other two getter function. That's the empty. Is the bool to check is that empty or not. It's not empty the stack. So that's why you need to see the difference. So here the empty we want you to do is to see if is this stack empty. So that's return bool. Or we can know currently how many objects in the stack. So that's the size. So they both are getter function. Yeah, so actually here the push and pop will be settled because they will update the information into the stack. The pick here actually should be the getter function as well because we just want to see the value. We are not touching that. So yeah, and also the other one, the empty is to see if this stack is empty. But then we have clear, right? So the clear is the setter function. So they should pop all the object from the stack. So what is the stack in the real life? Yeah, so next example, we will show you the stack example is a playing card. So you know usually your playing card, you have the face down, right? So you have face down. So that's why actually when you see a deck of cards, actually you need to have the bottom card to be in the deck first, then the deck to the top. So the stack for the playing card actually is one kind of stack. Or the other one we see more example is you put the plates. Now because sometimes playing card you guys will feel weird. I can take out the card, then I can take any cards in between, right? But then the other one you can see the heavy plates. You go to the buffet. Sorry, we cannot go to buffet now if we are sheltering in place. No buffet. Yeah, but before you see all the time you go to the buffet, you will see they will have a lot of plates there. So then, yeah, you only can pick the top of the plates. If you try to get the middle, then yeah, you either break all other plates or yeah, something wrong. Or you are a magician, you can do that. Yeah. So anyway, that's the stack example. But actually, the stack example we use a lot is for the computer memory. So did you remember we talked about? We say the stack memory actually is in the memory in the stack. So then this one is important is yeah, let me see if I can show you example. So the other one actually is we call the stack memory. We use that a lot in the computer memory. So we run a program. So we just say, for example, so what is stack memory? It's like this. Okay. So we just say if you have a function. So you have function 1. Okay. So then they have one argument. Okay. So inside this function 1, I call function 2. Okay. So 2. Okay. So that's what we say the stack memory. So stack memory we use a lot is in the when we run the program, the computer memory. Okay, so here we just say you have argument 2. So maybe function 2, we are not calling anything. Okay, so you implement 2 functions. So then we have, so we just say, for example, in the main function, we call function 1. Okay, so then in your function 1, you call function 2. Okay, so then function 2 finish, function 2 will return. Okay, so of course, after you finish your function 1 will return. So that's what we call the stack memory. So the stack memory in the main function, when they call function 1, right? So we know later they will come back. So then actually you have a return address. We just say that's fine. This return address is after we finish function 2, they will come back here. So then you see function 2, you have argument. Okay, so this one is we call stack memory. So when you have stack memory, you see you have 1 by 1. So then they occupy the value or the location. So after you see your function 2 finish, so you return. Yeah, so when you return, after you return back to the function 1, right? So you see here, this memory location is the last one you push in, but this one will be first one being released. Okay, so I just cross line mean they release. So then you see they release. Okay, so when they come back to the function 1. So then after you finish function 1, right, so you return. So when you return, every time when we return, before we return back to the main function, so then those memory will be released. So this one is, you see, that's why we call the stack memory. Because stack memory, the memory you use, you push in, push in, push in. But the last one you push in, they will be released first. So that's the stack. Actually, we use a lot is in our computer memory because the memory occupied first, but the memory will be released last. Okay, so that's another example about the stack. But the most important thing here, let's see the playing card stack example. Okay, so we just told you that we have a playing card, right? So each card you have your suit, you have your number. So we just say we have playing card, we have A, B, C, and D. So then these 4 cards, so when you create a stack, remember your stack is a template library. So then the data type is our playing cards chart. So I create this 4 objects. So then I create a stack called this card pile. So you see, we just add the card 1 by 1. But when you push A, push B, push C, push D, so then their order is, you see, A actually will be on the bottom, then B, C, and D. Yeah, so for human, we'll feel like, oh, A on the bottom, B, C, D, but you see in the stack, if we say that's stack memory, they just do A, B, C, and D. But no matter what, you see, even your A put here, right? But actually, we know this D is the last one. So that's why here, when we want to pick, I will pick the D. Because even you say, oh, you order like that, but we push this way, but we pop also this way. So that's why you will see, if we have a pointer or some location, we will remember where is the last one we push in. So this one is the location I will do the pick. So I pick, actually, remember the pick, actually you return a constant reference. So that's why you can look at the value, but you cannot update. So then when I pop, right, I pop D first. So after I pop D, right, so then the size only have A, B, and C. So 3 cards left. So then if not empty, so empty we just see if the size not equal to 0 is not empty. So then when we clear, one thing is we either pop everything or we just make the size equal to 0. So this one is our stack example. So this one actually you didn't implement any library yet, but this one can help us to know when I implement my stack template, what the public interface I should have. So that's why you see I have the push, I have the pop, I have the size, I have the empty, I have the clear method. those public methods should be included in my public interface.